All right, finishing up chapter 12 and getting ready for our quiz. In the first three questions, they ask us to determine if the sequence that is given is arithmetic, geometric, or neither. And once we find out which of these the sequence shows, then we're going to either find the common difference or the common ratio and then write the rule for the sum of the first n terms. So in this first example, first problem, it would help if we list a couple of terms. So this is a sub 1, a sub 2, and if I know n is 1, I plug in 1. 4 times 1 is 4, plus 3 is 7. If n is 2, I have 8 plus 3 is 11. 3 times 4 is 12, plus 3 is 15, and then 19. So if we just look at each of these terms here, I notice going from one to the next, I am always adding 4. So that tells me, because I'm always adding, that this is arithmetic. And my common difference is 4. Now with this arithmetic sequence, we want to find the sum of the first n terms. So we're going to use this formula. So the sum of the first n terms is n over 2 times a sub 1 plus a sub n. If I plug in the information I know, if I'm finding the first n terms, I'm going to have n over 2. I'm going to substitute a sub 1 is 7, and I'm going to add that to a sub n. Now to find the nth term, I'm going to keep an n here, and I have 4n plus 3. So this is really n over 2 times 4n plus 10. Now I could simplify this a little bit more. I can divide each of these terms by 2 or factor out of 2 and then cancel. So this is actually n times 2n plus 5. And I'm going to leave it in that form. In the second problem, if we notice, I have a sub 1 is 5, and then I have negative 5/3, and then positive 5/9. So this tells me I have alternating signs. It means I'm multiplying by a negative. Okay, so I'm multiplying by a negative, and I put negative 1 here, but if I even look at the denominators, if this is a 1 and then this is a 3, times 3 is 9, times 3 is 27, what I am actually doing is multiplying by negative 1/3. So because I'm multiplying, this is geometric. My common ratio is negative 1/3. And now I need to find the sum of the first n number of terms. So looking back at my formulas, I'm going to use the sum of first n terms equals the first term times 1 minus r to the n over 1 minus r. All right, so the first term is multiplied by all of this. So if I plug in what I know, the first term is 5, and then I have 1 minus r to the n, and I'm putting this in parentheses just because this is a fraction and this is a factor of that fraction. So 1 minus r to the n over and that r is negative 1/3 to the n over 1 minus negative 1/3. So 1 minus negative 1/3 is 4/3. Minus negative is plus, so I'm adding them together, I get 4/3. And if I multiply or take 5 and divide by 4/3, I'm going to have 5 times the reciprocal, which is 3/4. So this is going to be 15/4. And then I have 1 minus negative 1/3 to the n power. And that is the rule for finding the sum of the first n terms. In example 3, I see here that I am adding 1 to the numerator each time and adding 1 to the denominator each time. So let's look for a common difference. So if I do 3/4 minus 2/3, that will give me 1/12. And if I do 5/6, minus 4/5, that will give me, I'm going to do this on the calculator real quick. That gives me a decimal, and if I want to know what that decimal is, I can change that to a fraction. I just hit the math button, change it to a fraction, and that's 1/30. That's not the same as 1/12, so this tells us that it's not arithmetic. All right, so it must be geometric. So I need to find the common ratio. So I need to divide. I'm going to do 3/4 divided by 2/3, which would be multiplied by the reciprocal, 3/2. That would be 9/8. And then if I did 4/5 multiplied by the reciprocal, the number before it is 4/3. That would be 16/15. These are not common, so it is not geometric. So in this case, it is neither. It's neither geometric or arithmetic. It does not have a common ratio or common difference. For problems 4, 5, and 6, it says to find each sum. So on number 4, if we use the properties that we have in our notes, this is 3 times k, and to find the sum from 1 to 50, I can just pull this constant 3 out and multiply that by the sum from 1 to 50 of k. Now, in our properties, we have a list of formulas, and that rule was 3 times n plus 1 over 2. So n in this case is 50, so I have 3 times 50 times 51 divided by 2, and if I just do this on a calculator, basically I'd have 25, 50 divided by 2, times 3 is 75, and 75 times 51 is 38.25. All right, so the next one. This time I have a summation of number of terms from 1 to 30. So this is a square, and if I look back at my formula, if my rule is squared, I'm going to have a formula which is n times n plus 1 times 2n plus 1, all of that over 6. So now I'm going to plug in 30. So this is 30 times 31. And then 2 times 30 is 60, plus 1 is 61. And this is divided by 6. And if I calculate those numbers, 30 times 31 times 61 divided by 6, I get 94.55. All right, so number 6. This is a geometric sequence, and R is 1/3. So if I want to find the sum of this geometric sequence, I'm going to use the formula that we just used up here, where I start with a sub 1 times 1 minus r to the n over 1 minus r. All right, so this is a geometric sequence. My r is 1/3. So if I want s of n, the sum of the first 7 terms, so this would be s sub 7, my first term would be, if I did k is 1, 1/3 to the first power is 1/3. That's my first term. And then I have 1 minus 1/3 to the n power over 1 minus 1/3. All right, so on the bottom here, I have 1 minus 1/3. This is 2/3. And since I'm dividing by 2/3, I'm actually going to bring it up and multiply 1/3 times the reciprocal of this, which is 3 over 2. And by the way, n in this case was 7. I forgot to slip that in there. So this gives me 1/2 times 1 minus 1/3 to the 7th power. Okay, so that's 1/3 to the 7th power. Sorry, that kind of got all squished in there. So now on my calculator, I'm just going to put in 1/2. So I have 1/2, or I can do 0.5, times 1 minus, and then I have 1/3 to the 7th power. So in parentheses again, 1/3 to the 7th power, oops. And then I want to, oops, I want to go back. I want parentheses here. There we go. So I have 1 minus 1/3 to the 7th power, all of this times 0.5, or 1/2. And that gives me 0.4998. And that would be the sum of all those terms. Now, a few minutes ago, I changed a fraction to a decimal. I can go back here. I can change this back to a fraction by saying, okay, I push the math button, and the first term in the menu is fraction, so I'll push that. And they're just saying, do you want your answer written as a fraction? Yes, I do. So this would be 1093 over 2187. So either one of these answers would work. So 1/3 to the 7th power, if you leave that as a fraction and take it away from 1, then multiply it by 1/2, this is what you get. All right, next one, number 7. It says to find the 95th term of the sequence. Okay, so n is 95. So if I find a sub 95, that's the 95th term. I'll write the formula over here. A sub n equals a sub 1 plus n minus 1 times d. All right, so n is 95. The first term is 3. And then plus n minus 1, so that's 94. And my common difference, this is going up by 4. So if I want to add the first 95 terms, I start with 3, and then I add that to 94 times 4, and I get 379. Number 8 says to find the 11th term of this sequence. By the way, I knew in number 7 to use this formula because I was going up by 4 each time, and it was arithmetic. This time, my sequence is going up by a multiple of 2. So that makes this geometric. So this was arithmetic. And this one down here is geometric. So the formula for the geometric sequence would be, I want to find the 11th term. So a sub n equals a sub 1, first term, times r to the n minus 1 power. So a sub 11 equals my first term, which is 1, times my common ratio, and my common ratio I'm multiplying by 2. So this is 2 to the n, which is 11, minus 1 power. So 2 to the 10th power is 1024. Number 9. We want to find the general formula of the arithmetic sequence if the 7th term is 31 and the 20th term is 96. So I don't know where we start. I don't know what the common ratio is. I don't know anything that goes between the 7th and 20th term. And this is one of those questions where we might need to set up 2 equations. So I know that the 7th term is 31 and the 20th term is 96. And here, 31, if I use the formula, this is a sub 1 equal, or a sub n equals a sub 1 plus n minus 1 times d. So if I plug in what I know here, I don't know the first term, but I do know that n is 7, so I have 7 minus 1 is 6 times d. So this is one sentence, and for a sub 20, I know that I still need to find a sub 1, and this is 20 minus 1, which is 19 times d. So this is where I set up two equations. So I have a system of equations. If I add, or in this case, if I subtract my equations, if I subtract the a sub 1's cancel out. 31 minus 96 is negative 65. The a's canceled out, and then 6 minus 19 is negative 13. So in this case, d is going to equal 5. If I divide both sides by negative 13, the common difference is 5. And I can find the first term if I plug in 5 here. So I know that 31 equals the first term plus 6 times 5. And this is 30, subtract 30, so the first term is 1. So the general formula will be this. So this will be a sub n equals the first term, which is 1, plus n minus 1 times my common difference, which is 5. Whoops, 5. Okay, so I can simplify this. This is 1 plus 5n minus 5, distributing here. And then this is 5n and then minus 4. And this is the general formula. All right, so number 10. This one talks about geometric series converging or diverging. Now remember, if we have a common ratio that is between 0 and 1 with its absolute value, then it's going to converge, which means it's going to add up to a specific number. If my common ratio is bigger than 1, then it's going to diverge. It's going to just go to infinity or negative infinity. So if I look at this sequence right here, this is divide by 3. It says that these are geometric series right here. So I know that to get from one to the next, I'm going to do the same thing from one term to the next. So to get from 3 to 1, I'm going to divide by 3. From 1 to 1/3, I'm going to divide by 3. Or my common ratio is 1/3. I'm going to multiply by 1/3 each time. And this is less than 1. The absolute value is less than 1, so it's going to converge. And if it is going to converge, then we have a formula to find the sum of all those terms is a sub 1 over 1 minus r. So the first term is 3. And then I have 1 minus r, which is 1/3. And this right here is 2/3. So this is the same as, let's do this, 3 times the reciprocal, which is 3 over 2. 3 divided by 2/3. 1 minus 1/3 is 2/3. So I have 3 over 2/3, which is 6. It's supposed, oh no, it's 9/2. Wrong problem. So this is 9 over 2, and that is the answer. This one, my common ratio is right here. So my ratio is -5/4. And this absolute value is greater than 1. So this is not going to diverge or converge, it's going to diverge. That means it's just going to go, in this case, because it's negative, it's going to go to -infinity. On part C, my common ratio here is 1/2. That is less than 1, so this is going to converge. My first term is 3 because my first term, I'm going to put in 1 here. 1 minus 1 is 0. Anything to the 0 power, this part is 1. And 1 times 3 is 3. So my first term is 3, and my common ratio is 1/2. So using this formula back here, I'm going to have the sum of an infinite series is going to be a sub 1, which is 3, over 1 minus 1/2, and 3 divided by 1/2 is, this is where I get 6, and that's it. All right, so that's it. We're not doing the partial fraction decomposition. You can thank me now for that, but you should be ready at this point to take your quiz. All right, that's it.